Hello everyone. I feel honored to have this opportunity to share with you our research experiment and results. First of all, please allow me to briefly introduce myself. My name is Huang Shuman and come from Zhengzhou University, Zhengzhou City, Henan Province in China. The title of my presentation is an accumulated energy encoding model of the Pigeon optic Tectum accounting for the difference of response to moving and flashed stimulus. My presentation mainly includes 4 parts: background, main method, results, and conclusions. Firstly, I will give you a brief background on this study. Previous works had shown that tactile neurons were sensitive to dynamic stimuli, but not to stationary ones. Well, these results were all obtained in vitro whole cell recordings, and a model was also proposed to predict the properties. However, validation of these results were all based on electrical stimulation of retinal ganglion cell axons and tactile cell dendritic endings. Response to artificial electrical stimulation must be different with that to real visual stimulation recorded in vivo. And the existing neuron encoding models can't explain this phenomenon. Here we propose hypothesis that a moving stimulus could cause sequential activation of dendritic endings, and then resulted in accumulation of spike number, which could decrease response latency to the next stimulus. To verify this hypothesis, we established a new encoding model based on Generalized Linear Models Framework, GLM for short, which further explained the detailed difference between neural response to moving and flashed stimuli. The model mainly consisted of 3 sets of filters, including a Gaussian filter, an energy accumulation filter, and a post-spike filter. The main difference of our model from the traditional GLM was the stimulus filter part. An accumulated energy filter were added in our model to describe how tactile neurons accumulated external increasing stimulus. The simulation results of our model show that the predicted neuron data presented significant correlation with recorded response to moving and to flashed stimulus. Furthermore, the predicted responses to moving stimulus were faster and stronger than that to flashed stimulus. The predicted responses were much consistent with recorded response, suggesting that our model could capture the difference between response to moving and to flashed stimulus. Finally, we come to the last part's conclusions. The above results confirmed our hypothesis that response difference to moving and flashed stimulus may resulted from sequential activation of neuronal dendrites, providing a possible explanation of understanding potential mechanisms for detecting moving targets by avian. That's all. Thank you for your attention. Welcome your questions for further discussion.